find all absolute extrema of f of x equals to 4 plus x times log of x over x on the open interval 0 to infinity. So when you have an open interval and you have to find the absolute extrema, then you really need to know the behavior of the function. So you need to find the critical numbers, and then using test points you have to figure out whether the function is increasing or decreasing, and that tells you the absolute extrema. Okay, so let's take the function and let's differentiate. Now there are several ways to differentiate this. You can use the quotient rule. You can rewrite this as x to the negative 1 times 4 plus x ln x and use the product rule. But the easiest way to differentiate this is actually to split this into two fractions so that it becomes 4 over x and x ln of x over x. You split this into two. Now this is an algebraic equality. I haven't differentiated yet, so make sure that you put the prime to remind yourself you're still not done with the derivative. You still have to differentiate after simplifying. But we're almost there. It's 4 over x plus ln of x. And I want you to memorize these formulas. 1 over x prime is negative 1 over x squared. And ln of x prime is 1 over x. So using that, we see that the derivative must be negative 4 over x squared plus 1 over x. Okay, now why did we do this? Well, we did this because we need the critical number. Critical numbers are where the derivative does not exist or derivative is equal to 0. Now, this derivative does not exist at x equal to 0. However, 0 is not in the domain of this function, right? The domain of the log function is from 0 to infinity. And since we are only considering the function from 0 to infinity, and 0 is not part of this open interval, 0 is excluded from being considered as a critical number. So all we need to do is to figure out when this is equal to 0. I want to know where f prime is equal to 0. And when you have fractions, the best way to handle equations with fractions is just multiply everything by the denominator so that it's not a fraction. So I'm going to multiply by x squared both sides. And x squared and x squared cancels if you distribute. Right? X squared times negative 4 over x squared is just negative 4. 1 over x times x squared is just x. 0 times x squared is 0. So x is equal to 4. Okay. So x is equal to 4. Now what do we do? X equals to 4. Let's see. X equals to 4. That's the critical number. And the next step is to draw the number line. Let's draw the number line and put that critical number here. And because our interval is from 0 to infinity, 0 will be like the left end point. You can't go beyond this left side. Okay, so it's from here until infinity. And the 0 to infinity is now broken into two intervals by this critical number, right? And once you put the critical numbers on the number line and figure out how many intervals it divides, then for each interval pieces, what you need to do is to pick a test value. I like to pick like 10 or multiples of 10, 10 or 100, those are easy to calculate. Okay, so I'm going to pick 1 and 10, and you want to evaluate these numbers into your f prime, because f prime if it's negative, then we know that the function will be decreasing. F prime, if it's positive, then we know that the function will be increasing. Okay, so we are going to evaluate, let's see, f of x is this, right? F of x is negative 4 over x squared plus 1 over x. So f prime of 1 is equal to negative 4 over 1 squared plus 1 over 1, which is negative 4 plus 1, which is negative 3. So you get negative 3 here. Or just negative. Actually, 3 is not important. We just need to know that f prime is negative. And beauty of this test point is that if it's negative, then f prime will be negative between this interval. From 0 to 4, it has to be negative all the way. And then f prime of 10 would be negative 4 over 10 squared plus 1 over 10. So negative 4 over 100, what's that? Negative 0.04, right? 4 divided by 100, that's 0.04. Plus 1 divided by 10 is 0.1. So that's easily like 0.06. Value is not important. You just have to easily see that, of course, 1 over 10 is bigger than 4 over 100. So this is going to overpower this negative, so it's going to be positive. So that's all we need to know. It has to be positive. Now what that means is that your function f would be decreasing until 4 and then increasing afterwards. Okay. Now another thing that you realize is that this function here, when you see, let me just write over here. See, f of x is 4 over x plus ln of x. And you see, when x is like 0 plus, if x is like 0.0001, something like that. Oh, sorry, I can't say that. Just realized that this will be. Okay, so let me say something here. Ln of very big number still gives you infinity, okay? So since I know that f of x is this, if you simplify this, just like how we did it, we know that f of x is 4 over x plus ln of x. Because ln, when you have infinity in there, that's infinity, this grows up, up, up without bound. Just goes up, 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 okay? And therefore, there is no absolute maximum for this graph, okay? So let's draw things again. So here's what we know. We know that the function f is decreasing and then increasing. And it increases without bound as you go further to the right, although it increases very, very slowly. That's the nature of log functions. Log functions, they increase, but they increase very slowly, okay? So it does increase, and because of that, this point 4 is the point where the function has the absolute minimum, but this means that the function will not have absolute maximum, okay? Because it increases without bound. If that happens, there's no absolute maximum. Absolute maximum is the highest point of the graph, but what is the highest point of the graph if the function just increases up, up, up? There's nothing you can call as highest. Whatever number you say is the highest, there's still something more beyond it, okay? But f of 4 would be the minimum because that's what we just figured out, right? So let me change the color. Let's evaluate the function f at 4, which is 4 over 4 plus ln of 4. Okay. So I'm using this formula that we figured out that f of x is 4 over x plus ln of x, right? So from this, when I plug in 4, this is what I get, and that's equal to 1 plus ln of 4, and that is absolute minimum. And therefore the answer is no absolute maximum, and absolute minimum is 4 comma 1 plus ln of 4. And I also drew this in a graphing calculator, and this is how it looks like. So it's really hard to judge from the graphing calculator. Actually, for this problem, even with the graphing calculator, you'll be having really struggling trying to figure out what's the minimum because it's so flat here. Okay, but the calculus tells us that the minimum is right here, which is 1 plus ln of 4.